Hi there, welcome to Walk-thru about topic 2, average velocity. I want to start this off by just saying that we've been talking about changing position, and that's called displacement. And we've been talking about that change of position over a certain amount of time. Now, unless we really zoom in very closely on that change in time, making the change in time very, very small, like insignificant, like just really, really, really small, we have an average velocity over a certain time span. It's just by definition, you just get a sort of like averaging of a chunk of time. You get a change in position over that time. So when we talk about velocity, when we find velocity, what we're really finding is a change in position, which is the displacement over the change in time. And because it's a change in time there, it's necessarily average. So the way that we represent this with an equation is like this. And let me show you right here. So I'm going to start with the purple here. We've got velocity, and it's a vector. Sometimes people denote vectors with this little arrow on the top like this, or just an arrow over the top like that. Sometimes average velocity is denoted with an average sign that looks just like this, except missing the little arrow tip right there. But this velocity is an average velocity. It's not instantaneous velocity, which we'll talk about shortly. And this instantaneous velocity is represented by delta S, which is the change in change in position over the change in time. So this delta S really equals the final position minus the initial position. We use S as our position. That's our variable for position. The little subscript right here is called, that's for final, and this is for initial. This is going to be with respect to time. So we have TF, it's a subscript F. Didn't quite write it right there. And there's a T. Actually, it looks like a T. TF minus TI. That's the change in time, and this is the change in position, otherwise known as displacement. So that's our formula for velocity, for average velocity, not instantaneous velocity. This is average velocity. Another formula that we can use for average velocity, which I think makes a lot of sense. I'm going to use a different color for it. I'm going to use bubblegum for this. This other formula for velocity, for average velocity, I'll just use V right here, V with a vector again, or just a V with a bar over the top. That means average. I could have used that over here as well. This velocity is initial velocity, which I'm going to use the variable u. I know it is a little bit weird, but sometimes people use u to show the initial velocity, plus the final velocity divided by 2. And that's what we normally think of as when we say an average of something. We say like the start part minus the final part, and then divide by how many parts there are. There's 2. So if we say like we want an average height of people, if one person's a meter tall, another person's 0.5 meters tall, you add those heights together, and then you divide by 2. So if you want to find an average velocity, take one of the velocity values plus the other velocity value that you're given, and then you divide by 2. If there are more than more than 2 velocity values, we would just add up more of those and then divide by how many there are. It's just kind of a normal way of describing velocity. We won't use this so much as we use this. This will be our bread and butter. So get used to that. What else? We are going to be calling these things speed, or you can call this velocity, or you can call this like fastness if you are comfortable describing it that way. We haven't really defined what the difference is between speed and velocity is yet. On purpose, because I just want it to feel more natural right now. But let's take a look at some problems right now. Oh, and I should say before I go on to any problems that if this initial position is, let's say, bigger or greater than this final position, then you're going to have a negative value here. So you're going to have a negative velocity, and that's okay. You can have a direction with this velocity since it is a vector, and we will talk about vectors shortly. I don't expect you to know what vectors are yet. Just know this is average velocity, and you can have a positive value or a negative value. Okay, so let's go on to the warm-up problems. I'm going to take a screenshot of this. Don't save. Okay. Here it is. So we've got, I'm just going to start off with the first warm-up problem and then go on to the first part of the second warm-up problem, so you have an idea of how to solve these. The first part says determine the average velocity of a rolling soccer ball during the time interval 0.1 second and 0.4 second. Report your answer in centimeters per second. Okay, so this is centimeters. That's our position right here. If it was in meters, we could convert this. I hope you could convert that. We are going to go through some more conversions later and how to do conversions a little bit more explicitly. But for now, we're safe. We're in centimeters and we're in seconds. So we want to find the average velocity between this point right here, that time point, and 0.4, which is that time point right there. And that correspondingly, it's going to be, it looks, if you go up right here, straight, if that was a straight line, and you go straight up over here, and I think this is a straight shot. I'm trying to make it as straight as possible. That's as straight as I can get. Sorry. Right. So what do we do now? Well, we look at this little equation. We say, okay, back to this original equation. I'll use a purple for that one. Our velocity, our average velocity, I'm going to use just a regular line right now to show average. It's going to be our delta S over delta T. So our final position minus our initial position all over our initial time and our final time right there. So it's going to be final time minus the initial time and final position minus the original position. So all I'm going to do right now is simply plug in the values. So the final position in this time interval is 80 centimeters. So 80 centimeters, and we're in the units of centimeters. That's what we want to report our answer in, centimeters per second. And our initial position is 20 centimeters. So it's 80 minus 20. And the final time is 0.4 seconds, 0.4 seconds, and our initial time is 0.1 second. Okay. So put this in your calculator. It's going to be, I'll just simplify this first. Whoops, 60 centimeters divided by 0.3 seconds. Now I'm going to use a calculator here just because I am not trusting my mental math right now. Okay, what would this be? Calculator. All right, I'm going to bring the calculator over here. It's going to be 60 divided by 0.3 equals 200. Great. So our final answer here is 200 centimeters per second. And we're not going to worry about this crazy thing I'm going to describe later called sig figs, or significant figures. We're going to talk about that soon. Don't worry. You'll love it. So our final answer is 20 centimeters per second. Next, we get the position versus time graph shown below of the motion of a confused little squirrel. I say he's a confused little squirrel because he's going away from the origin, and then he's coming back to the origin, and he's staying still there, and then he's moving away from the origin. So it asks, what is the average velocity of the squirrel during the following time intervals? And there's more of them down below, but I'm just going to do the first one. It says, remember to use correct units. Our units are going to be in meters per second. Meters per second. Okay, so the time interval 0 to 5 seconds. I'm going to use exactly the same equation as I used up there, so I'll keep with the purple. Our velocity is going to be the change in position over the change in time. So our change in position would be 30 minus 0. 30 minus 0 is, guess what? 30 meters. And all over the time is going to be just 5 seconds. I'm sorry, 5 seconds. So it's going to be 5 seconds minus 0 seconds. So overall, it's going to be 30 meters over 5 seconds. We want to reduce it as much as we can. We're going to make that calculation. I'll use a calculator just because I can. 30 divided by 5 is, you know it, as 6. So it's 6 meters per second. I'll write down 6 meters per second down here. 6 meters per second. Great. You can use 6m over s. I know what s means. It's second. So I hope that makes sense. Let me know if it doesn't. This is a fairly straightforward thing here. I just want to make sure that you understand the main point, which is that this is an average velocity between this time interval. If you get a shorter and shorter and shorter time interval, you get closer to something we'll call an instantaneous velocity, which is a velocity at an instant. But because there's a time interval, if we specify a time interval, it's not going to be a velocity. It's going to be an average velocity. Okay? All right. And so that's a change in position over a change in time. That's all I have for you right now. I hope you enjoy those practice problems. Okay, bye.